What's up, guys? Let's take a look at another CodeWars exercise. This one's called U.S. Postal Codes. Given the name of a U.S. state or territory, return its postal abbreviation. So if we got Indiana, we'd say IN. If we got Kentucky, we'd say KY. And they even give us a list of all the inputs and outputs. So there's no surprise in there. But the thing that makes it interesting is the size of your code is limited to 500 characters. If we tried to make a dictionary of all the inputs and outputs, that would be 700 or more. And if we added the code to look it up, it'd be about 8. So we have to find a way to trim it down. And this is a common thing in computing. Maybe you don't have enough memory and you have to find a way to compress. Or maybe you don't have enough processing power and you have to find a way to do less work or do it beforehand. And in this problem, it's a little bit of both of those, because when they say your code, they mean the data and the function all together. We might save some strings, we might do some work, and together that whole thing has to be 500 or under. So what's going to help us here is that they're not random. Just like when we talked about Morse code, you don't have to choose a combo for E and Z equally long. You can say, well, E is super common in most European languages, in all the languages that were doing Morse code in the 1800s, and so we'll make E a single tap because the English speakers and the German speakers and the French speakers use that all the time. And then we'll make Z something longer because we hardly ever have Z. I think maybe in Italian they use it more. So right here we can say these are not random. Like Alabama's not QF and Alaska's not HO. They're definitely related to the letters somehow. So I took a minute earlier and put these into 4 categories. We've got some that are the first 2 letters. That's slightly bigger than the other categories, but they're all about the same. And we got some that are the first and last. And you can see why they did this. Like with Kentucky, KY is a lot more recognizable than if I saw KE. I wouldn't quite get it at first which state it was. Then we got the ones that are initials, where they have 2 or 3 words, and you take the important letters or the first letter from the first and last word. And then you got some that are just other. Now it makes sense why they chose these. Like with Texas, you know, the X is clearly the most interesting letter, so they put it in there. Or with Arizona, the Z is clearly the most interesting letter, so they put it in there. But it's hard to tell a computer to do that unless we have some kind of analysis of the rarity or something. So I'm going to put these into 4 categories, and I'm going to say, how can we tell the computer to check 4 things instead of 50 things? Because if you remember at the beginning, I said writing all this would be about 700. But doing this, if we have to make a dictionary of these, well, that's fine. Like, that doesn't take all our characters. In fact, let's do that to start off with, because I might not be able to programmatically figure these out. I might just have to list them. So let's say worst case scenario, I just have to list all of these, and we'll start with that. I'm going to have a dictionary, and these guys are going to have to be in strings. If I was doing 50 of them, I'd probably write some code to turn them into strings with the quotes, but for now I can just highlight and put some quotes. And then I want to turn these commas into colons to make a dictionary, so I'm going to hit Control H. Boom, there we go, and then I'm going to put these in quotes as well. There is a cute way to avoid the quotes. With the dict function in Python, D-I-C-T, you can have like keyword arguments basically, and so we would be able to cut some of these quotes, but I'm going to try to do it. I'm going to try to do this problem in a very normal way that looks like it was written for human eyes. I know you could probably compress this into some horribly ugly thing with strange bytes that get translated into other bytes, but I'm going to try to make it look reasonable. So what should we call this? I think I'm going to call this other, because it's the last category. It's the ones that don't quite fit in to anything else. I could just call it D for dictionary, and that would be a fewer characters, but I'm going to try to make them labeled with readable names. So let's use that. Let's say, well, we'll do those. We'll return other of the state if state in other, else nothing. So we'll at least test those. And hey, we got one right on our quick test, and on the attempt we should get about a quarter of them. Yeah, we got about a quarter of them because these are about 4 roughly even patterns. So let's do going up. I think the initial ones will be pretty easy, and all we have to do is see if there's a space in there, and we do the initials, right? Some of these guys in the exceptions don't fit into that, but if we're checking the other first, then that will rule them out, and then we can do the initial second. We don't have to worry about these guys. So, that was the solutions. We're going to look at those later, but I'm doing one that's different anyway. So let's say, if there's a... By the way, we could do this return expression as one line, but it would be really super long and really hard to fit in your eyes or on the screen. So I'm going to break it up into a few lines with these parentheses. And yes, that does count against our characters, but it'll be fine. So I'm going to say, if our guy is 2 words, we're going to go state dot split 0, 0 is the first letter of the first thing, plus -1, 0 is the first letter of the last thing. If space in state, else. I've just got our empty string as a fallback, but of course at the end we won't have that. Now if I hit attempt, I should get about half of them. Yeah, we get about half of them because we've done 2 of our 4 categories. So now we have to say, okay, which one should we do? Because we're only going to do one of these. The 4th one is just the else. It's just the otherwise. It's just the last thing that we don't have to check. If we just do these 3, and then we say, oh, well, it must be the first 2 letters if it hasn't been any of the other ones. And it does seem like the first 2 letters is slightly longer. It's a slightly bigger group. So I'm going to use that as our fallback to be the last group. So for these guys, we use the first and last initial. I think we're going to have to mention them. I don't think we're going to be able to test the string with some rule like the last one had a space. So I'm going to copy these and paste it in here, and then I'm just going to delete all the abbreviations because we're going to generate the abbreviations. But I'm going to say, hey, let's make a big old list or a big old string that contains these and check inside of it. Again, this is kind of tedious, but I'm willing to do it once. Okay, so I'm going to call that first, last, and maybe we'll have to make our name shorter or something, but I'm going to try to make them readable. So we can say, okay, else state 0 plus state -1 upper, because remember we have to upper it. The A at the end of California is naturally lower, but we have to make it capital CA for the abbreviation. If state in first last, else whatever. So now we should pass 3/4 of the tests if we try. Yeah, we passed about 3/4. And the last one we don't have to list. It's just the fallback option. So we can say state, the first 2 is like slice 2, again dot upper. And now, hey, look at that. We passed all but 1. Is that just the code size, or is that something actually being wrong? I think it's just the code size. So we're at 612 and we need to get down to 500, which is not that bad. Like, we've got a lot to work with. We could do some really cheap stuff like making the parameter shorter, like just calling it S. Let's go ahead and do that because that will save us a lot. Maybe enough. No, not enough, but it will be quite a bit. Let's try that. Okay, 612 to 576, so that gave us, 40-ish. Now, I could space these out or not, or take out the spaces, but I don't want it to be dependent on that. I want it to look good without everything squished, and I also want it to be, solid enough that we're not scrounging the last few spaces like coins out of a couch cushion. We're making it look nice and giving ourselves a foundation to work with. So if I hit attempt right now, what are we at? 578. So we got to cut a bunch. And obviously, we're going to have to cut something from these strings. So how much do we need to identify one of these? Is it the first two? No, because there's right there a CO and a CO. So the first two is clearly not enough. What about the first three? COL, CON? I think the first three is enough on these guys. So let's try that. This is sort of what people do when they're reading. Like when you're reading and your eyes are just blazing across the page, you don't really read the whole word. You just kind of see the first or the first and last, and you make some assumptions because your brain wants to do less work and identify things as quick as possible. So like this, all of these are unique, and I think the first three is more than enough to identify these guys. So let's just say if S first three isn't first last. Oh, now we're really close, right? Now we're down to 510, and we're doing it in a readable way. Like if I saw that, I would know, okay, these are the ones with the first and last letter, and here's how you find them. And so this other is probably where we're going to cut from to get our nice solution. This is looking okay to me. Like if I saw this, I would be able to figure out what they were doing. And how can we trim these? Well, the first three is definitely not enough here. Like Mississippi and Missouri, first three is not enough. First four is not enough because those are the same. First and last is not enough because those are the same. And this guy is really going to be the troublemaker, northern, because if I check for north, then I can find North Carolina or North Dakota. And I kind of have to check the other thing first because it might cause trouble in other situations. So let's say 5 characters. Let's go with the first 5 and then deal with the north separately. So something like that. Yeah. This guy, I'm just going to pull out, and it'll be its own separate thing. I hate to do this, because you always hate to have like one weird exception at the top, but let's go ahead and do it. MP if, and I don't even need the whole string, I'm just going to say if Mariana is in there. And then we need to slice 5 characters for this guy, which I think would be that. And hey, nope, we messed something up. What have I done? State. Oh, I said state. I forgot to cut that and make it S. I should have used the Control H, find replace, like I did earlier with the comma colon thing. So now what have we got? We failed one, and it's an interesting one. It's like one of the states instead of just being a typo or something. UI for Virgin Islands. Oh, this guy, I didn't cut that to the first 5 letters, which is a weird looking one, U.S.space. Maybe we should cut that and do it separately just for the visual factor, because that looks insane. But let's try it. Okay, and 480, so we really could squeeze in more stuff. Like we could do the Virgin Islands separately. But that is pretty nice, and it allows us to make it readable. right? Like I didn't have to cram these all into one long line. I didn't have to translate into crazy bytes. I was just able to trim with extremely readable stuff. Like if you saw this, you would know what we were talking about, and if you saw this, you would know, except for maybe that one. That's the troublemaker. So let's take a look and see other people's solutions. Some of them might be nice and readable. Some of them might be crazy algorithms that cram it into 100 characters. Who knows? Right here, this one's kind of cute, where everyone has a different length abbreviation. Like Alabama, you need 4, because ALA, well, that still could be Alaska. But the B narrows it down enough. Whereas with some other ones, like IN, that's enough. Like once you see IN, you don't need to go further. That's narrowed it down. But we couldn't have done that with our dictionary. They're using a different approach, which is the starts with method on strings, after zipping these to say, okay, if it's in there, and then next is very cute. Next is like what for loops do when you're iterating through something. It goes to the next one. So this is like checking each one. Maybe inefficient if we have to check 50 different things before hitting it on the 51st, but it is very cute, and I'm sure it's a lot fewer characters than mine. This one, kind of a similar thing, where, how are they doing it? They're using the index method to look up various short abbreviations. I find this one a lot harder to read than the previous, and the previous was already kind of hard, so not a fan right here. This one is harder to read, but in a cool way, which is every character has its own number value, because obviously the computer doesn't know what an H is or whatever. It's stored as a number in memory, and the Unicode value is a small number for letters and common characters, and then it's a big number for things like emojis. But most characters we use are fitting into a single byte, and the ORD function gives you, a number of what that byte would be. So the one that it starts with is capital A is 65, and so you could sometimes do math with those to take your character, put it in a number form, do some transformation, and then back into character form. The most classic would be capitalizing. You just, the alphabet capital is lined up a certain point, and then lowercase is lined up a certain point, and if you just plus 90 whatever, then it shifts it to the other one. And this guy's doing something kind of like that, but a lot more complicated, which is pretty cute. This one is kind of like mine, but way more specific. So instead of 4 categories, they've got like twice as many. And for them, Iowa was the weird one. Like for me, Mariana was the weird one. But for them, somehow Iowa was the one that didn't fit. They're checking the first and last. They're checking, oh, this is kind of cool. They're checking like, okay, some states specifically use like the first and fifth, or the first and fourth, or whatever. And I don't know about that. That doesn't really seem very easy to follow for me. But it is kind of cute that this person was able to really trim it down to just ifs and no dictionary or anything. This one is even wilder with the bytes, because they got some wacky characters, and I don't get it at first glance. I hit their clever upvote a minute ago before I started recording, but not because I know what this guy's doing. Div mod is kind of interesting, because it's like making change. Like you figure out how many big chunks and then how much left over. So I'd be interested to look into this and see what this person is doing. But anyway, we could keep scrolling and find some interesting stuff like these characters. My guess is what they're doing is these characters are more than 1 byte in Unicode, or UTF-8, and so they're saying like, hey, what if we pretended that they were single bytes, and so like this long thing broken up into shorter things, and we interpret those as something else, then it just transforms into a totally different number, which is kind of cool. This one is the last one I'll glance at in this video, but that was kind of cool because they just look up the table on the Wikipedia page and pick the answer out of it, and the question tried to ban that by banning import, but you can just kind of fake it by putting those together, which is very fun. So I love this problem because the restriction creates some opportunities to either do something really wacky or just trim on basic categories. Like if I were doing this on paper, if I were doing this 100 years ago, there was no machine, I would still put it in these categories. I would still say, okay, there are some where it's the first two, and there are some where it's the first and last, and there are some where it's the initials. And in fact, that is, of course, what happened when people made these. They didn't algorithmically write code. They just thought about what made sense. Like, yeah, obviously Texas is TX. There's nobody would ever put TS for that because X is the recognizable thing, and you just find out which ones work like that and which ones don't. So I really like this one because it's a good way to think and it's a good way to practice getting around some restrictions.